Welcome back, Algebra 1. This is Lesson 4.2. I'm Mr. White. Some essential understandings. What we need to do is look at the value of one variable may be uniquely determined by the value of another variable. And we're also going to look at relationships may be representative using words, tables, equations, ordered pairs, and even graphs. So this is the function machine. Here we go. We have seen how mathematical expressions can be thought of as machines too, except instead of slicing, grading, hauling, and grinding, the purpose of mathematical functions is to do certain operations on whatever number goes in. For example, the function performed by the expression 2x minus 4 is to find 4 less than twice the number that went into the domain value. Okay, so if we look at number 1, we have an in and out with the function in the middle. So if we look at this number 2, if we input 2 into some function and out comes 7, we need to figure out, well, what's actually happening in the function. So if we put something that's in, and we're going to get this output. Okay, so if we input 8 into the function, out comes 13. If we input 20, out comes 5. So what we need to figure out is, well, if we input 35, what comes out? Well, if you notice, each time we're adding 5. So if we put something in and we add 5, then we get our output. So if we input 35, if we add 5, you get 40. So our new answer over here is 40. Number 2, we're taking a function. We're going to input something and then again get an output. So if we input 6, out comes 3. If we input 10, out comes 7. If we input 15, out comes 12. So what is actually happening? Input, output. Hopefully you notice you are actually subtracting 3. So we're going to input a number, subtract 3, and get the output. So 23 minus 3 equals 20. Number 3, we're looking at domain and range. Remember, domain is really your input or x, and your range is y, or your output. So if we're going to input 5, and then we're going to get an output of 15. So we're going to get input of 2, output of 6, input of 100, output of 300. Couple thoughts. If you normally were we were just adding or subtracting numbers. Well, if I add 10 to 5, you get 15, but I cannot add 10 to 2 and get 6. So we know we're not going to add. Doesn't look like we're going to subtract, so then we look at maybe division and multiplication. So 5 times what equals 15? So 5 times 3. So then we double check and say, is 2 times 3 6? And the answer is yes. Is 100 times 3 300? Yes. So what are we doing? We're taking our domain and we're multiplying by 3 to get the output. Or, in this case, the range. So if we input 25, 25 times 3 ends up giving us 75. Okay, go ahead, hit pause. Try 4 and 5. We'll see you back here in a couple minutes. Go. Hey, welcome back. If you look at number 4, you should have had the domain divided by 2.5 equals the range. And the way we did that is, first I looked at adding. So if I took 10 and tried to add something, if I go 10 minus 6, I get 4. But if we go to 2.5, 2.5 minus 6 doesn't give us 1. So it's not adding, subtracting. So then I look at multiplication. So I want to figure out, well, what am I going to multiply some number x to 10 to get 4? Or what am I going to multiply some number 2.5 to x to get 1? So by simple solving, if I divide 4 by 10, you get 4/10. If I divide 1 by 2.5, you get 1 over 2.5. What's really happening is we're dividing by 2.5. Okay, on number 5, okay, we're trying to think again, how do I get from 2 to 3, 5 to 24, 10 to 99? Well, if you notice, if we try and add 1, you're going to go 2 to 3, but 1 from 5 makes 6, so that's not 24. So adding is not going to work. Multiplying, tough to look at the 2 and 3, but 5 times probably a decimal is going to get you 24. So the next thing after you look at multiplication, we try and look at division. Division doesn't make really much sense. So based on this, we would next look at to maybe squaring. So if I take 2 squared, okay, that gives me 4. But how do I get from 4 to 3? So I can subtract 1. Okay, so that gives me 3. Then if I go 5 squared, it gives me 25. But 25 is close to 1. Again, if I minus 1, you get 24. So that worked. So if I go 10 squared, minus 1 gives you 99. So it was taking the domain squared minus 1 equals the range. So when we plug in 7, we're going to go 7 squared minus 1. Your answer should have been 48. Okay. Jump back over to 4. If we are dividing by 2.5, we're going to take 17.5. So 17.5 divided by 2.5 should give us an answer of 7. All right, 6. We're taking some domain number. We're going to apply a square root. So if we take the root of that domain number, we are going to get our range. So if we input 9 and we take the square root of 9, you should get 3. Okay, if we take the square root of 64, yes, you get 8. If you take the square root of 16, input, we get 4. So then if we input 36, you should get 6. Next function machine, we're going to take our in. We're going to input a number. What are we going to do? We're going to multiply by 3 first, then we're going to add the 1, and then that gives us our output. So if we input 0, we're going to go 3 times 0, then add a 1, which ends up being 1. Okay, if we start with 2, we're going to go 3 times 2, then add 1, so we get 7. If we plug in 10, we're going to go 3 times 10, and then add 1, and get 31. So the last one, if we're going to multiply negative 2 times 3, we'll get negative 6. And then if we add that 1, we're going to get negative 5. 8. Notice we're setting up almost like points. So we have our x value here, and we're going to then take our x value and input into the y part, or the second part. So we're going to take our 0, and we're going to input it into the x squared next to the negative 16. And what we're going to do is we're going to square the 0, multiply by negative 16, and then add 100. So you end up getting 100. Okay. So for the second one, we're going to go negative 16 times 1 squared, add 100, which gives us 84. So if we keep doing that, negative 16, 2 squared, plus 100. Be careful, remember, we're going to square 2 first, then multiply by negative 16. So 2 squared is 4. 4 times negative 16 is negative 64. Negative 64 plus 100 is 36. And the last one, if we square 3 to get 9, we'll have 9 times negative 16 plus 100, and we get negative 44. So last one, number 9, go ahead, hit pause. Try the function for the absolute value of 3 minus n. Go. Welcome back. So if we input the values, you should have had input 0, output it becomes 3, input 2, out comes 1, input 5, out comes 2, and input negative 4, out comes 7. Alrighty. So now when we look at patterns and linear functions, okay, this represents a geometric relationship. In the diagram below, we need to figure out, well, what is the relationship between the number of rectangles and the perimeter of the figure they form? Okay? And then we need to represent this by using table, words, an equation, and a graph. So one thing we can do is, first we have the number of rectangles on the bottom, but we need to figure out in terms of perimeter. So I know that there's a 6 on this side, a 1 here, so if I count the total perimeter, I know the perimeter is going to be 14. If I do the same thing, and we have 2 1s on the bottom, I know the perimeter is going to be 16. If I add now a third triangle, I still got 6 over here with 3 more 1s, so we get a perimeter of 18. And if I add another rectangle with the 4 lengths, we get a perimeter of 20. So we need to represent this relationship using the table. So we can make a table in terms of, let's call it rectangles, and let's just use it as an X. And then we can say that our perimeter is based on the number of rectangles, which could be our Y. So we start off with 1 rectangle. We went to 2, 3, and 4. And we figured out that our perimeter was 1 rectangle was 14, 2 rectangles was 16, 3 rectangles was 18, and 4 was 20. So in words, what we're trying to figure out is how are we getting the perimeter for each additional rectangle. So if I wanted to put in 5, if I wanted to jump all the way to 10 rectangles, how can we figure out the pattern that's actually coming about? Alright, so what we can do, if we want to transfer this in words, we just hit the button, and what we're going to do is we're going to multiply the number of rectangles in each figure by 2 to get the total length of the top and bottom slides of the combined figure. Then we can add 2 times 6, or 12, for the total length of the left and right sides. Again, so what you'll notice is every time we go on the sides, it's always going to be 12, or there's 2 6s every time, no matter what. So what's really happening on the sides, the top and bottom, is each additional rectangle that we're adding 2 extra sides. If I look at the number of rectangles, what I'm really doing is, if I jump down here to the table, is I'm taking for what rectangle, we're going to have 2 of those single sides. So we're going to multiply 2 times 1 rectangle, and then we always have 2 6s on the sides. So that gives us a perimeter of 14. So we can write this as a pair of 1, 14. Another way of looking at this is if I go back to the table at the top that I created, if I look at how am I getting from 14 to 16? Well, we had to plus 2. Okay, how am I getting to 16 to 18? That's a plus 2. How am I getting from 18 to 20? That is also a plus 2. So since we have a constant that keeps increasing, what we can do is we can take that constant and multiply that to the number of rectangles, or x. So if I take that constant 2 and multiply it by the number of rectangles, okay, and this is going to help us get the y, or in this case, the perimeter. Okay, now hopefully we would actually have what we need. So if I go back and check and say, okay, if y equals 2 times, let's take the number 3. So 3 rectangles. So if I input 3 rectangles, you get 6. So right now we have a perimeter of 6, but we're supposed to get to 18. So how do I get from 6 to 18? We have to add 12. So our equation that we can come up with is y equals 2x plus 12. So if we're going to fill out the table using what we have, if I take the perimeter with, so now if I have 2 rectangles, I know that the number of rectangles where the red one is going to increase, so we have 2 times 2, plus that still, the 2 sides are still the same, so now we have 16, okay, which gives us a point of 216. If I go 3, we're going to go 2 times 3, gives us 18 when we add the 12, so now we have 318, and 4 gives us the 20, so 420. If we needed to graph this in the relationship between the number of rectangles and perimeter, and if we did that, we would actually have this graph here, which where we use is the y-axis is what we call the dependent variable, and we also have the x, which is that independent variable. Okay, so that y depends on having the x. If you notice, these are all in a nice straight line, so this is a linear model, or represents a linear function. Problem number 2. Okay, the table over here shows the relationship between the number of photos x you take and the amount of memory in megabytes left on your camera's memory chip. So if we just think about this, what happens to the memory as we take pictures? And obviously, the more pictures you take, the memory is going to go down. So if we look at the table, is this a linear function? And then describe it in the words in the equation that we have. So we notice, so it starts at no photos, we have 512 megabytes, and then it is going down. Well, if we draw our little arrow on the side and say, well, how far is it going down? It is going down about 3 megabytes. And then from to 2 pictures, we're going to go from 509 to 506. So now we have 3 megabytes. And from 506 to 503, we have also 3 megabytes. So since the constant is going down each time for memory, then we can take that constant and we can multiply it to the number of photos taken, or call it x. So we know that y is equal to 3x. Okay? If we input, say, 1, if we plug in 1, we'll end up getting 3 times 1, which is 3, but we need to get over to 509 megabytes. So how do we get from 3 to 509? We take and we have to start off at that initial 512. So we have plus 512. Now if you notice, one thing that I left off is what was actually happening with the megabytes is we were decreasing the megabytes with each picture. So we need to make sure we have a negative here. Okay. So the equation that we have is y equals 512 megabytes minus 3 times x. Or in words, we're going to take the amount of memory left on a chip in 512 minus the quantity 3 times the number of photos taken. If we graph this, we know that the number of photos taken would be your x, and then the memory left would be your y, so we get something like this. Notice the scale, big numbers, again. Notice though at the bottom with the x-axis, we actually label it with number of photos. The y-axis was our memory. Problem number 3. We need to take a set of points or order pairs and then determine if they are a linear relationship and then explain how we know. So if we kind of start off how we were doing with the tables, if I just concentrate here on these x's for a minute, okay, notice what's happening is the x's are going up by 1. So for each increase of x, 1 to 2, 2 to 3, 3 to 4, it's going up by 1. What's happening to the y value? So the y is increasing from 5 to 10, so that's plus 5. From 10 to 15, that's also plus 5. 15 to 20 is plus 5. And 20 to 25 is plus 5. Since we have a constant that goes up plus 5 each time, we can say, yes, this is a linear relationship. So for each increase in 5 units of y, we also have an increase in 1 unit of x. Or if you flip it around, for each increase in 1 unit of x, we have an increase in 5 units of y. So for each 1 unit increase in x, there is an increase of 5 units in y. Okay. So B, we want to do the same thing, determine if the set of points is linear. If we start with the x's again, we're going from 0 to 1 to 2, so the x unit is increasing by 1. We have a negative 3 to negative 5, negative 5 to negative 7. So as the x goes up 1, we actually have a decrease in 2. Okay, so if I just put this y and this x this way. Then we get to 2, and now we have an increase in 5, or increase to 5, excuse me. There is an increase of 3, so if it goes up 3, then we are going from negative 7 to negative 15. So we have negative 8, or minus 8. And then now we're going from 5 to 10, so we have an increase in x of 5. But we go from negative 15 to negative 25, so there's a decrease by 10. Okay, if I look at the 3 ratios that I kind of created, going from an increase in x of 1 to a decrease in 2 with y, and then also when we get to the 2, we jump up 3 with a decrease in 8, and then we get to 5 and we increase the x in 5 with a decrease in 10. Notice these ratios. You have a negative 2 over 1, you have a negative 8 over 3, and a negative 10 over 5. These two are pretty much the same ratios, where this negative 8 over 3 is not, so this is not a linear relationship. All right, don't forget to practice on patterns and linear functions. And remember, do your best, forget the rest. Bye for now.